A 3D geometry viewing demo is used here to manipulate 3D objects. This teapot, containing 2,304 garrote-shaded polygons, can be freely rotated and scaled. The light source can also be interactively moved. This room, rendered with radiosity techniques, contains over 19,000 polygons. Here too, the light source can be interactively moved. The room can also be interactively scaled and rotated. A mesh outline of the polygons is added here. This demo is running on the 4 processors on the MVX Accelerator and is being displayed in the 32-bit VX frame buffer, which is digitally keyed into the system display. In this demo, U.S. geological elevation data is represented first with color-coded vectors. These vectors are being calculated by the GX processor and displayed in the 8-bit GX frame buffer, both of which are included on the VX Accelerator board. The mesh density can be increased in this demo for greater detail. Now the terrain is represented with nearly 40,000 triangles. By loading a Landsat image of the same terrain into this window, the position of the eye point and gaze point can be set with the mouse. The dual frame buffer design of the VX, which contains both the 8-bit GX frame buffer and the 32-bit VX frame buffer, allows applications to take advantage of both, as this demo does. The VX processor is now used to texture map the Landsat image onto the geometric data. This is being displayed in the 32-bit VX frame buffer. The SunArt high-quality rendering tool in SunVision 1.1 can run distributed across many processors. Here it is running on the 4 MVX processors to render a teapot with a wood grain texture. The distributed SunArt tool can also run across multiple Spark CPUs on a network. This demo also uses CSG, constructive solid geometry techniques, to carve out spherical sections from the teapot. This demo ray traces a 5,000 polygon snake in 6 seconds. All 5 processors on the VX and MVX accelerators are being used. A variation of the JPEG image compression standard using discrete cosine transforms was used to compress each pre-computed frame of these movie loops to an average of 0.5 to 0.75 bits per pixel. Running on the VX and MVX accelerators, the movie frames can be decompressed and played back at rates of 20 to 30 frames per second. This movie was created using SunArt, the RenderMan-compatible high-quality rendering tool that is part of SunVision. The rendering of the frames was done in parallel on the 4 MVX nodes and on Spark CPUs on the network. The movie loop can be stopped, and a slider can be used to display individual frames within the movie loop. The frames of this movie were created using Sun's volume rendering tool. The images are shaded volume renderings of a 50 by 50 by 50 numerical simulation of an air duct over a heated plate. The rendering shows the temperature distribution in the air duct. The data is courtesy of Sandia National Laboratory. The frames of this movie were also created using Sun's volume rendering tool. The images are shaded volume renderings of 61 MRI slices of a human head. This data is courtesy of Jeff Shaw, Vanderbilt University. The frames of this movie were created at Numerical Design in Chapel Hill, North Carolina. An infinite loop of twists and turns can be played. The movie tool can scale the image by a factor of 2 using a pixel replication algorithm. For further information on Sun's visualization workstations and the VX and MVX accelerators, please refer to the VX MVX datasheet and technical white paper.